x. 8 minus 4 over n. So it's 4 over n. Prep number 2. Not easy. So it's the starting point plus I delta x, which is 4 plus 4I over n. Okay, I am going to write it, because it's 4 and 4, I'm going to write it like this. You'll see in a moment why. And now in prep number 3, in this function, I need to plug in this. So, f of xi is 4. 1 plus I over n to the third plus 2 times this is easy, and plus 4 is easy. But this will take a while to raise this to the third power. 4 to the third is okay. It's 64. 64 times 4 is okay. How much is 64 times 4? 256. But I have to take 1 plus I over n to the third power. One plus I over n to the third power is 1 plus I over n squared 1 plus I over n. When I square this, I get 3 terms. The first term squared plus 2 times the first times the second plus the second term squared times this. Now I distribute 1 to these 3 terms. Now I distribute I over n to these 3 terms. And now I combine my terms and arrange them in the correct order. I to the third over n cubed. I squared, 3. I squared over n squared plus 3. I over n plus 1. This happened only because the starting point was not 0. That's why I had to do this. It took us a while. But it's just algebra, so we did it. So now I'm back. I'm back where? Well, 4 times 4, because I have to cube it first and then multiply by 4 by the order of operations. Again, 4 to the third is 64 times 4. And now I have to copy all this. I cubed over n cubed plus 3. I squared over n squared plus 3 I over n and plus 1. What is this? Just this. Plus, now I distribute 8 plus 8I over n and plus 4. And now I have to distribute 256 to these 3 terms and then combine like terms. So 256 I cubed over n cubed. It's the only term with I cubed. This is going to be the only term with I squared. So I will multiply 256 by 3 because I'm lazy. 768. I squared over n squared. So this is done, this is done. Now, this is the same number, 756. This times 3i. And I have to add 8 to it. So, 776 I over n So now these are done. And now I have 256 plus 4, I have 260, 268. I will absolutely, and I always do, I will make sure that when you have to determine this on test 4 or on final exam, I don't want to, we have to see at least one. So this is a perfect example. But I will not start from any other number but 0, because I don't want this to take 15 minutes. Okay? I just want to see that you know the technique. And this is just these are just the preps. We haven't even gotten to the limit of the Riemann sum yet. But now we are there. So let's start. So the exact area will be the limit Sn approaches infinity. N approaches infinity from the sum from I equals 1 through n, delta x, 4 over n. And then this, all this, 256 I cubed over n cubed plus 768 I squared over n squared plus 776 I over n plus 268. I can put that page away. Okay, now remember the properties. Remember the properties of the summation or sigma notation. This depends on I. This one does not. So I'm going to move it outside because it's a constant. Then I'm going to apply the summation notation to the first term, and then summation notation to the second term, and to the third and the fourth. So limit Sn approaches infinity from 4 over n. When I apply the sum to this becomes a constant. 256, or it's a constant and not becomes, it's a constant that goes outside. So the sum of I cubed. When I apply the sum to this, 7068 over n squared goes outside because it's a constant, and we have the sum of I squared. Plus, when I apply the sum to this piece, then 776 over n, and then the sum of 1, the sum of I, and this is 268, the sum of 1. Okay, let's stop for a moment, and before we continue. So first of all, I took the constant outside. That's the delta x. It does not depend on I. It's always the same, like we did here. Remember a few minutes ago, Amanda was asking, what is this? Well, that is the base, right? The 2. That's why it's this. So I took it outside because it's a constant. Awesome. Then I apply the sum to this, but when I apply the sum to this term, this is the constant now that goes in front of the summation notation. This one. When I apply the sum to the next term, then this is a constant. It goes outside, and I have the sum of I squared. When I apply the sum to this term, this is the constant that goes outside, and the sum of I. And here we understand that this is 268 times 1. 268, when I apply the sum to this, 268 goes in front, and it's the sum of 1. That's exactly what we know. That's all we know to calculate. These are those 4 formulas from last time. Each and every one has to be replaced by what it equals to. Any questions so far? Is everyone with me? Can I continue? Is it clear what we're doing?
I think it's clear.
Yeah. Okay. So then, remember, this piece is n squared, n plus 1 squared divided by 4. This piece is the ugly one. It's n plus 1, 2n plus 1 over 6. This is the nicer one. It's n. And this is okay. It's the same thing but not squared. So it's n plus 1 divided by 2. I have to replace all these by what they equal to. And then find the limit. Because once these disappear, everything is an expression in n. And n goes to infinity. Moving on. Is this okay? Any questions? Okay, so let's write it. Again, these calculations are cumbersome because we wanted to see an example with the interval that does not start at 0. Limit as n approaches infinity, 4 over n. So I have 256 divided by n cubed times n squared, n plus 1 squared divided by 4. I will divide and simplify as much as I can. 256 divided by 4. Is that 64, right? Yes, of course. So that's 64. And then I cross out 2 of these, and 1 is still left in there. Plus 768 divided by n squared times n. Remember, I have to multiply these two. So I have 2n squared plus 3n plus 1. Everything over 6. Can I divide 768 by 6? I doubt. Oh, awesome! 128. Awesome! And 1n goes away. So I'm done so far with this, and I'm done with this, but now I'm here. Plus 776 divided by n times n plus 1 divided by 2. And finally 268n. 268n. I will simplify by 2. And 7 divided by 2, I have 3. In 17, I have 8 and 8. Am I correct? I can divide tonight. I was able to. Okay, so then we have limit as n approaches infinity, 4 over n outside, and the least common denominator. Notice that I don't simplify here. The least common denominator is n in all cases. And of course, this one needs to be multiplied by n because the denominator is 1. Okay, almost there. 64 times that. So 64 times n squared plus 2n plus 1. Plus 128 times 2n squared plus 3n plus 1. Plus 388 times n squared plus n, and plus 268 n squared. All these are all in the numerator. The denominator has just n. So right here. So limit as n approaches infinity. The denominator now is n squared. I still have a 4 outside. And now I'll calculate 64. That's with n squared. Plus 128 times 2. That's with n squared. Plus 388. 388 and plus 268. They're all with n squared. 268. So I had a 64, I had 128 times 2, I had 388, and I had 268. Okay. So 976 n squared. Now I'm collecting the terms with n. So 64 times 2, 128, plus 128 times 3, plus 388. These are all the terms with n, plus 900n. And now finally the term that is a free term. So I have a 64, I have a 128, and that's it. 192. Now, yes, we can use L'Hopital's rule, but there is no need because it's the leading coefficient over the leading coefficient. So the answer is 4 times 976. My goodness. 3904. No, you're not going to look at something like this. I promise. But it was a good practice. Any questions? Any questions?
Could you go up just a little bit?
Yes. Of course. I guess too far up because of the other camera. That's what.
No, that's fine. Dude.
No, but I'm trying to adjust it so it's better. Okay. Moving on. Do we understand how we approach this summation notation? And these are the only formulas we have. We don't have anything else. Okay. So a minute ago, we came up, more you than I did, which was perfect. We came up with this function. That's my page 7. I'm going to write the function again. 4x to the third plus 2x plus 4, and the interval was 4, 8. So it was a very good pick. The question is,